Welcome to this problem session for the other trigonometric functions, and I'm just going to do a small number of them, one for each of these. So we're going to start out with the tangent and cotangent. Here is the normal equations: y equals k plus a tangent bx plus c, respectively. We use the cotangent, a curved vertical shift k. This is not an amplitude, it's a coefficient a. The period looks different for tangent and cotangent as it does from sine and cosine. So its period equals pi over b, not 2 pi. The phase shift looks the same, negative c over b. Okay, so first we're going to graph y equals 1 plus tangent 2x minus pi 4. So we have a phase shift of k equals 1. We have a coefficient a of 1. Yes. We have a coefficient b equals 2. Sorry about this format here. Which means we're going to have a period of pi over 2. Okay. The coefficient c equals negative pi over 4. And the phase shift is going to be negative times negative pi over 4 divided by b, which is 2. Therefore, we're going to come up with a phase shift of pi over 8. Pi over 8. I'm just going to jot these down here for a moment, and then we're going to do the cotangent. So the equation for the cotangent is y equals negative pi 1/2 minus 3 cotangent of pi x plus pi over 2. So the shift is minus 1/2 down. The coefficient a is negative 3. So because of that negative in front of it, what's actually going to happen is that cotangent will be reflected about the x-axis. So instead of going down, it will be going up, and therefore the cotangent will really look similar to a tangent. The coefficient b is pi. Since for the period it says pi divided by b, so pi divided by pi, this one comes out to 1. So a period of 1. And we have a coefficient of plus pi over 2. So we're going to end up here with negative pi over 2 divided by b is 1. I'm sorry, b is pi. So we're going to come up here with negative 1/2 for the phase shift. Again, I'm going to jot these down. Okay, and we're going to graph these. First one, which was y equals 1 plus tangent. Oops, there's already parentheses. I think I'm just going to clear it and start over. So 1 plus tangent 2x minus pi over 4 Okay, and then I'm going to go to the window where my x minimum, I have a phase shift of pi over 8, and with that minus in there, that actually means that the phase shift is positive, so we're going to start the positive side. So I'm just going to call my minimum x value as 0. We have a total period of pi over 2. So if I just go to pi over 2, actually plus the pi over 8, so maybe I'm going to go to roughly 2. We should be able to just catch one period. And for the y min, y max, well, because it stretches quite a bit, -5 to 5 or -9 to 9. Let's do that, -9 to 9. There is a vertical shift in there of 1 as well, and we'll see that slightly being shifted up, but not a whole lot. Okay, here we go. And there we can see 1. Period. If I give it a little bit more, if I increase the window, in fact, I think I can just zoom out. That might just work. There we go. Okay, now we get more tangents here. You see these little dark black bars right on top of the x-axis. That means that's where the tangent flattens out, and that's where the vertical shift comes in. It's shifted up by 1 rather than being on the x-axis where it becomes horizontal. It's just shifted up by 1. Okay, we're going to do the other one, which is -0.5 minus 3 times cotangent, which of course means instead of times we divide by the tangent. Instead of multiplying by cotangent, we divide by the tangent. Pi x plus pi over 2. So there we go. Now I'm going to go to the Windows setting. I have a phase shift of -0.5, so we may want to start there. -0.5. Period of 1. So I could go to 0.5, respectively. If I go to 1.5, we're going to see a couple of periods, and then it's going to be as flat. And a y minimum, well, maybe not -36 as I had just zoomed out, but so maybe -15 and 15. We have a relatively large coefficient A of 3, so that will stretch out quite a bit. And notice that negative in front of the 3 cotangent actually flips it around the cotangent, so it's also going to go up just like a tangent curve rather than a cotangent, and that's what we can see right here. Yeah, so it sure looks like we have a period between -0.5 and +0.5, and we're graphing 2 of such periods. Let's do the cosecant and the secant, and then we're done with this problem section. Okay, so for the cosecant and secant, we have y equals k plus a cosecant bx plus c, respectively secant. K is a vertical shift. We have a coefficient a because we're on an amplitude. The period is back to being period equals 2 pi over b because they're the reciprocals of sine and cosine, and the phase shift as it's always -c over b. The first one we're going to graph is y equals -2 plus secant 1/2 x minus pi over 3. So we have a vertical shift of -2. We have an amplitude of, not an amplitude, a coefficient a of 1. We have b equals 1/2. Period comes out to 2 pi divided by 1/2, which of course is 4 pi. There we go. We have c equals -pi over 3. So we have -pi over 3 divided by b, which was 1/2. And we come up with +2 pi over 3. Pi over 3. The other one is going to be y equals 1 minus 1/2 cosecant pi x plus pi over 4. So we have a vertical shift of 1. We have a coefficient a of 1/2. So that just turns the cosecant around. The reflected, that is. The coefficient b is a pi, so the period is going to come out to 2 pi divided by pi. Divided by pi, which means we have a period of 2. The coefficient c is plus pi over 4, so the phase shift is going to come out to negative pi over 4 divided by pi. Whoops, didn't mean to do that. Oh well. So we're going to come up with negative 1/4. Okay, I'm going to jot these down and then we're ready to graph them on the graphing calculator. Okay, so here we are in graphing these. We have y equals negative 2 plus, well, we cannot type in secant, so we're going to do 1 divided by cosine, 0.5x minus pi over 3. Okay, we're going to go to Windows setting. Here we have determined that we have a phase shift of 2 pi over 3. So actually our first one is going to start at 2 pi over 3, but I always want to have the y-axis in there anyway. The x maximum should then be the 2 pi over 3 plus a whopping 4 pi. That's what our total period is. So I add that to the phase shift of 2 pi over 3, and I might as well round it off to 5 pi. I think that's what I come up with. So 5 pi is the x maximum. That will get us a little bit more than 1 period. And the y minimum and y maximum, I might as well leave them like that. Let's see. Just want to double check here. It's going to be shifted down by 2, and we'll see that. But overall, of course, it has the vertical asymptotes and goes from infinity to negative infinity. So we have these large troughs there. Okay, that kind of looks like I made a mistake somewhere. Let me see that I find that on the Windows setting. I'm okay. On the mode, I'm okay. What did I do wrong? Oh, this is what I did wrong. I forgot the x. Put the x in there, right there. Right there. Just calculated one cosine value and that was it. So there we go. So what you see there is that the secant starts beneath the x-axis. That's because we had that phase shift of negative 2 in there. Just like I did before, I'm going to put this into bold and graph the corresponding cosine, even though that wasn't required. But here it is, 0.5x pi over 3. There we go. And graph. It's going to be a rather flat cosine. Yeah, I guess I shouldn't have made my y value so large. Otherwise, we could zoom in there a little bit better. In any case, what we also can see here is when I trace it, that the phase shift comes out to 2 pi over 3, which is just a little larger than 2. So right about here is. So that's where our phase shift is 2. And then the other phase shift, then plus a period of 4 pi gets us up to, I believe, almost 15, and that's why I stretch it out to 15 over there. We can also see the vertical shift here. Notice that the vertical shift's at -2, but we're adding a 1 here, so that's why we come up with -1 right here. And then for the other one, we have a -2 minus a 1, and so we come up with a -3 right here. Okay, we're going to do the cosecant. So I'm going to clear these. 1 minus 0.5 times cosecant, respectively, divided by sine pi x plus pi over 4. The window setting is going to be, we have a phase shift of -0.25, so maybe I start out at -0.5. The period is pi, that's because, I'm sorry, 2, that's because the coefficient b is pi, which we had divided into 2 pi, so the period is 2. So if I go up to 1.5, we have exactly 1 period, actually to 1.75, but let me round it to 2. And then here, let's make it a little smaller, -5 to 5 perhaps. Maybe that works better for cosecant and secant. Of course, the two, it's hard to distinguish between cosecant and secant, just like it is hard to distinguish between sine and cosine, because if you put a phase shift in there, if you reflect one of them, like this one here is reflected with that minus in front of the cosecant, they kind of wash into each other. Again, we could see the phase shift, which should be in -0.25, and we can see that here that the cosecant starts out with a vertical asymptote. That's because, let me see if I get one more. Yeah, kind of barely. It's actually off the screen now. It starts out with a vertical asymptote because the cosecant is the inverse of the sine. Of course, the sine starts out with a 0. So at 0, you're at infinity or -infinity, and with a phase shift of -0.25, that's why we have very large negative y values right here when we have an x of -0.23, or if I go a little bit left, we have really large y values at an x of -0.26. So there's the phase shift of 0.25. We can also see the period of 2. Just after 2, it starts repeating over here. And again, as I did before, I'm going to make this one bold and then go down here and plug in the 1 minus 0.5 times sine, and is it pi x plus pi over 4. There we go. And I think we're going to have a really flat sine curve as well, because the amplitude for that sine wave is only 1/2. This time around, I can't talk about the amplitude because this is a sine curve, so an amplitude exists there. And with that, we're done with the problem section for this section on the other trigonometric functions.